Today we're doing a similar and kind of related problem to last time, except that instead of looking at single digit numbers, we're looking at 2-digit numbers with the associated spaces in them. So once again, we're going to be reading in this grid from a file. So we should do that, then we should figure out how we're going to parse this. It would make sense to put these 2-digit numbers in a 2D array because we are trying to find 4 numbers who multiply together to make the highest product in this grid. And that can be either horizontally, vertically, or either kind of diagonally. That's like down right or down left. I think it would be a really interesting exercise because humans are so good at parallelization and abstracting that spend about 30 seconds. Stare at this, whether you have it here, whether you have it pulled up on your own machine. See if you can find where you think the largest product comes from. What are the 4 adjacent numbers, either horizontally, vertically, or diagonally, that will give you the largest product? I'll give you a hint, it's not what's highlighted red. In case that wasn't obvious. I am unfortunately cheating, I know where it is.
I think I know someone's promising, but I'm gonna double check.
There are quite a few promising places.
That's just backwards.
No,
That's
it's different.
I'm dropping the 62 and I'm using the 73 on top.
There's that one.
What am I doing? Oh, I see. You skipped a 90, you skipped a 97. Oh, you did? Yeah.
All right, your 30 seconds are up. Do you think you found it? If you had to place a monetary bet on whether you found it or not, who would be confident that they found
I'm confident.
The question is, how big is it? Because if it's something I'm willing to throw away, I'm pretty big.
it?
No. I need some money. I'm confident. I can do it.
All right, where is it?
I like. Diagonals, right?
Maybe?
It says diagonal. So I believe,
Yeah, this way will be easier.
big numbers. 97, 99, 49, 52. I'm really just confident in these two.
Okay. Anyone agree? Anyone think they have something better?
Oh, you think you got them?
Come on up, Jimmy.
I like gambling.
Confusing.
Oh, I could have written mine down. Here, maybe this one right there.
Right there, 94, 99, 71.
Damn it.
Like I said, I like it.
Anyone think they have a better one than that?
Alright, that's mine.
Both of you are wrong.
Probably
Hey, you know, if I go down, at least Jimmy's going down.
And this is how professors get rich.
Take a shot. It's $1 buy-in.
You get it wrong, take a shot right now.
All right, so if we're not totally confident about where it is, maybe we can write a program that will identify where it is. So let's go through a process. Question?
Since you know the answer, can you give it to us?
Not yet.
Pretty pleased with the cherry on top.
We have to have something at stake for your program, right? So let's intuitively break this down a little bit before we get too started on this. So what process should we go through? If we were to break the program down into a series of components, maybe methods, what would the English description of those methods be?
Check valuable products.
Before we even get started on that, how are we gonna get this internally represented?
2D matrix.
2D array of some kind? We need to be able to read something in from a file, right? How are we going to do that?
File thing.
file thing.
Read
What methods of a scanner are we gonna use to grab these and how are we gonna place them in the associated structure?
Well, I need to have a file and a directory and then save.
So we could continue to use things like nextint, and that way we don't need to care about where the new line is. We could read in a line at a time and then parse the line. We could read next token, which would help.
To get it all in there, yeah, but then I see the problem. The problem I'm seeing right now is how do you get a diagonal line? How do you get that across?
So let's start thinking about that. All right, so last time we wrote basic syntax for how to read in from a file, so I'm not gonna repeat that part of this time, just because that's on a prior lecture that you can refer to. You can Google it if you want to figure out how to read it in from a file. Once it is in that form, once we have a file and we've at least opened the file, parsing this is gonna be slightly different. So parsing this, we want some way to read all of these numbers. First of all, what size should we make our structure? We have some kind of 2D array. What size should the 2D array be?
20 by 20.
20 by 20 for exactly this problem. It probably makes sense if we want to be able to solve this in a remotely extendable or abstract way to factor that 20 out somewhere. This makes sense for something like a static constant. So we make something like let's call this and then we can do exactly the same thing for num calls. If we do this, then we don't force it to be a square. If we only had one thing here that said size or something of the sort, we'd only be able to do it if the rows match the columns. This is more extendable if we allow it to be some kind of rectangle shape. So sure, we can force this into some kind of rectangle shape. So the number of rows is 20, the number of columns is 20. How are we actually going to go through this? We need some kind of 2D array list.
Nested for.
I would even argue that we can probably use a basic array for this. I don't think we need any of the functionality of an array list. I think we can just do this straight as ints. So somewhere we're going to have we're going to make a new 2D array of size num rows, num calls. And now the first element of this is going to refer to the current row we're looking at and the current column we're looking at. Now we need to find some way to loop through this file structure. We're going to assume our scanner is called, I don't know, SC. Somewhere there's a scanner SC that's pointed at this file that's ready to read from this file. So how are we going to do that? We need some kind of doubly nested loop. And we have some way of reading through this. What goes in the middle of this doubly nested loop?
Few digits and just
Yeah, we want to be able to say something like,
should be nums, not num.
we'll say nums of I, j equals sc dot next int. And if we're using next int, we're not going to have to worry about any kind of scanner related exception. because as long as the file is 20 by 20, we're making that assumption. We're okay if our program breaks and just stops with some kind of end of file related exception where there's no next int to read. We're making the assumption that this is 20 by 20. Maybe it would be worth throwing an exception if it's not, but I don't really see something that we could do about it. What would we do about that exception? We just have read the wrong file, or we've opened something that's not compatible with this. There's nothing that we can do in our code that will make this acceptable, where we can recover from that exception, so it's okay to crash the program. It's only really worth throwing an exception if we're going to be able to do something about it, or we need to communicate that to the end user. We'll skip all of that for now. So by the time this code completes, nums should look kind of like this. We have a 2D structure where this I, as we're filling it, represents the current row, the J represents the current column. And now we have this structure with I from 0 to 19 and J from 0 to 19. 20 by 20. All right, it's full of stuff. Algorithmically, how should we proceed? What do we want to do to this?
Get down to smaller grids.
Smaller grids, maybe? It's an interesting idea.
4 by 4 grid, and then you only need to look at the numbers in the X.
Well, in that case, let's say we did that. So I'm just gonna erase these semicolons. We need them, but if we're gonna draw something around this 4 by 4 grid, is this a valid combination that we need to check? So if we only have things like successive 4 by 4 grids, we're not gonna be able to check everything where the beginning comes from one grid and the end comes from another grid.
Yeah, yeah, it.
Yeah, we would need to do something like look at this grid next. Intriguing.
Just you only have to look at one setting at X.
And then, yeah, we would need to look horizontally through all of the possible horizontals, vertically through all the possible verticals. Now, what happens when we get to looking at all of the verticals for this one? Would we be doing 3 repeated things? This is column 2, 3, and 4 in this first rectangle. This first square and this second square, it's columns 1, 2, and 3. So we'd have to have some built-in logic for some way to know what we've already done, so we're not repeating unnecessary work. I would argue there's probably a slightly easier way to do this. It's a good idea, and I think it will work, but you may be doing more work than necessary, or producing logic that is more complicated than necessary, with more potential places that it could break. Idea?
I would do all the calculation necessary. So each, for example, one function will be of every combination of a horizontal 4, and then you have another function calculating all the possibility of vertical, and then all the cross.
Okay,
And then
intriguing.
and then throw that into a hash map and then figure out
All possible horizontals, all possible verticals, all possible diagonals. I think we can combine that into a single pass. If we iterate looking number by number at each individual number, what are all of the possible ways that we could produce something that includes 0, 8? We could look horizontally, we could look vertically, and we could look diagonally, kind of, or we could look diagonally. Is there any reason to look up? Is there any reason to look up left? Is there any reason to look up right? Or is there any reason to look left?
No, because those are repeats.
Yes. By the time we get to something like 23, when we go up, that was the down of 97. If we go left, that was the right of 52, which we've already seen. When we go up left, it was the down right of 0.8, which we've already seen. So of the 8 possible cardinal directions that we can look at from a particular location, we only need to concern ourselves with 4 of them. And it doesn't matter which 4, as long as we're consistent and they're one of the, like if you draw a line between this, we're only going to consider down right, and down left. So we're going to draw the line right here that separates these, so that these we're going to consider and these we are not. And that allows us to start from the top left and numbered by number, look at all possibilities of the lists of 4. We're gonna run into some potential issues as we do this. What's the big potential issue that we can run into?
When you get to the bottom, it's gonna look in empty space.
Actually, throughout the entire thing, it's gonna be doing that. Even from this 0.8, what happens when we look down left? We're out of bounds. When we get to the end of this, we're gonna start looking right out of bounds or down right out of bounds. So as long as we're close to one of the edges of this diagram, there are gonna be places that we can look that will be out of bounds. So we need to include some out of bounds checking. When we look right, what does that look like? There's a single check we can make that determines whether we should look at these 4 cases or not. What is the conditional that we should use when we look right?
Current index plus the next 4, adjacent 4 is if it's null, then just throw it out.
That's not gonna be null, it's gonna be greater than or equal to what? So we're assuming the x coordinate here is the column, basically.
Number of columns.
Yeah. What's the check for down? Because down is the other one that only has 1 variable.
Would be the
It's
column.
next equal null, like a null, something like that.
Look very similar to this, except instead, if we're keeping track of a particular x, y, where x is the current column, and like, so it's like it's looking at the x-axis. That's why I'm getting the x from, and this y is a y coordinate, so it's the current row. If we add 3 to the current row, then we may be out of bounds, if it's greater than or equal to num rows. Is this right? Anyone buy this? You shouldn't. This is gonna give you an off by 1 error. Where is that off by 1 error coming from? This is what produces the common index out of bounds exceptions that people see.
Because the furthest that you're gonna go is you're going from 0 to 19.
Yes,
So it needs to be less than, not less than or equal to.
yes. So this should be greater than or equal to num calls minus 1. But yeah, x plus 3, this, yeah, you're right, this should be less than and not greater than as well. X plus 3 needs to be less than num calls, and y plus 3 needs to be less than, not less than or equal to, num rows. Right? So these are the 2 kinds of mistakes that I see people make frequently. I made them on purpose. Changing the less thans to greater thans. And the difference between less than and less than or equal to. You could also say less than or equal to num calls minus 1, that's equivalent. But you need to make sure and think through what are the boundaries, what are the 0 indexed indices of the boundaries, and what does that mean for us? So this is the appropriate check that's going to determine whether or not we are out of bounds when we move only right or only down. The slightly harder ones, when we're looking at the diagonals, what things need to be true if we're looking at the diagonals?
Both of those have to be combined.
Yes. So when is there an issue here? Is it an and or an or? A Boolean and or a Boolean or? When are we out of bounds? When we're looking down right? I'll just kind of move this down here so that I can write it somewhere else that makes sense.
When that both true.
So do we need x plus 3 to be less than the number of columns? And we need y plus 3 to be less than the number of rows in order for that to be the case. If that's not true, then we're out of bounds either on the right side or on the bottom side. We don't need both to be true. We don't need to be out of bounds in both of these areas. Only one of them means there aren't 4 numbers to use. There aren't 4 numbers to multiply together. So now we can say x plus 3 is less than num calls. And y plus 3 is less than num rows. When we're looking down left, now it's a little bit different, isn't it? What is an appropriate Boolean condition that will help us determine whether or not there are 4 numbers to look at from a particular number when we go down left?
We still need the y plus 3 is less than num rows, but we also should make sure that we're not pulling something that's less than 0.
Yes.
So
So we'll continue this point because we're looking down, but we haven't done anything looking left yet. Yeah.
Minus.
So we can say y plus 3 is less than num rows and x minus 3
Greater.
is greater than. What tells us we're out of bounds? What's the boundary on the left side?
-1. So as long as it's equal to or greater than 0, we'll be fine.
Yes. So I'm gonna say greater than or equal to 0 to make it show that we could be on the edge. You could say greater than -1 here as well. That'd be perfectly equivalent, but I don't think it quite makes the level of intuitive sense as greater than or equal to 0. But a greater than is also in line with everything that we've been using so far. So whatever makes more intuitive sense to you, you can use there. They're equivalent. But that's the logic that we need to make sure there are 4 numbers that we can pull. So all that's left for us to do is just to go through and now say for each number, check all 4 of these. For whichever ones are true, pull the associated 4. So if x plus 3 is less than num calls, what do we want to multiply?
The current index.
We would want to multiply something like x times x plus 1 times x plus 2 times x plus 3. But only if this Boolean is true. If this Boolean is false, something here will be index out of bounds and throw an index out of bounds exception. So do we see how much thinking we've had to do? I have not had anyone start writing code yet. This is the amount of thinking that I like to do before I dive into any programming problem. Once you intuitively understand the problem that you are solving and have this in your head or on paper, preferably on paper somewhere, so you can refer to it as you're writing your code, you can see the layout of the logic that you need to construct. And that way you're not discovering things about the logic you need to construct in the middle of writing code. That's what produces so many bugs. Because you have to merge, how did I used to think about the problem that was wrong with how do I think about the problem now, which is hopefully correct, hopefully not still wrong, and then merge those ideas to what changes do you need to make. It requires you to continue to understand the way you used to think about the problem that was wrong. That's not good. So take the time to understand the problem correctly and then go implement it. That level of pre-planning and determining the logic in just kind of pseudocode. Is this actual code? Absolutely not. That is. But this process of what we need to do is just logic. It's just thinking about the problem and at a pseudocode level, and a logic level throwing it together. So now I think we can work and pair program and try to knock out this. There's one more thing we kind of need to think about, though. This is great. It will probably even tell you the product. If you do something like this and store, all right, x times x plus 1 times x plus 2 times x plus 3, what is the program going to print at the end?
+1.
It's going to print the value of the product. Is that useful to you? No, you don't know where it came from still. If we want to figure out where in this chart the answer came from, where is that embedded within this notation? Yeah, it's embedded in the tuple x, y. Right? Whatever x is the current column. Whatever y is the current row of where you are. Which means that this coordinate can help you identify where in the diagram it starts. Even if you know where it starts, does that tell you you need to know what direction to look from there? So we need to label these with something like a number that tells us you'll pair this with the value straight, like right, down, or down left. Once you pair that together, if you were to pair this with x, y, comma, right, it would tell you wherever this is, looking right, some numbers would get you there. All right, pair up, see if you can knock this out in the next, however long we have, 22 minutes? I think hopefully this gives you enough logic to be able to take this logic and produce code. But from what I've heard from the class, this is where we struggle the most when we take this conceptual idea and try to turn it into a logical program. So I think this is the appropriate place to pair program and knock your heads together and see if you can come up with the associated code. We'll go over some of it at the end of class. Let's get to it. There are an odd number of people in here, so there will be one group of 3. Yeah. Anyone attending remotely, you could message each other privately, talk this through. That was pretty good last time.
I expect you didn't have a conflict.
No, just so it will.
Download it right in the client. And then have them put it in.
Remember that in a pair programming environment, usually we have one person typing and one person thinking abstractly and communicating. If you're both typing, you're both doing one part of the pair programming, and you may be sitting next to each other, but you're not engaging with the pair programming process. So make sure that we have one screen that is working on code and both of you are working on that same program together. One of you is working on actively contributing to the program, and one of you is validating that what the other person is typing is correct and is thinking logically or intuitively, what's the next step, so that you can have a conversation as soon as the current code segment is typed about what comes next. How to do that.
It's fine. I have. We also don't follow up with this works. You should be on array, you should run things right along the array. This is work. Things, sort of things. So
Yeah.
oh yeah, because that's just a job over here. And then probably make a basic array of this one numbers. You probably just give something to say to you, just. So you can find out what the numbers were.
Oh, we have to create a.
Yeah.
Products.
Well, but it's still not even-
I guess we can do. So.
No.
It's math, it's math.
And then.
So I'm reading. There's that right here.
I should say.
Yeah, I mean, that's it. It's
Bug somewhere?
importing the text file.
Let me see if I can put that. Quickly.
So first we gotta get all that.
I didn't do
Um,
Should be this. Even technically.
Open your SRC folder. And that's a class directly in the SRC folder. Put the input package, you drag and drop it into your SRC.
Down there.
Right.
Yeah. So. I have to check every single.
Would that still wash the include a full file directory for it?
And basically.
It should work if you do it absolutely. No, it's still
Basically, they get files that figure
Done.
out.
it's not a file not found exception, it's an input mismatch exception. Found at line 18.
Yeah.
It's saying that the way that it's reading this is not as an input. It's reading something that's not an int.
Yeah, because whenever something's not, it has to change.
That's saved as is.
The string version changed.
Put back your code.
Also make it. Okay.
You only do that one.
So another way you can do this, if that's not working, is you can, instead of sc dot extent, there, you can say integer dot parseInt, all capitalized integer. It's not part of the scanner class though, so we can fed it, the entire thing, including the parentheses. Type capital I, integer dot parseInt. That's gonna take a string, and that string is going to be sc dot next. Then you may run into the concept of needing to throw in new lines or reading in new lines as tokens. Run it now and see what happens. You need to
It's a.
Oh, check those down.
So now, after your inner loop, do, so in between, after this more.
I see those.
Yeah, just do, you're gonna throw away, just do sc dot next one.
That seems a little messy.
So.
This is single file. You still get use.
So it's already. Roads.
Fill it in.
So it's.
Well, that's just what I call it.
Oh, okay, just, yeah, well, gotcha.
Yeah, see.
Cause you don't, oh, you pass. Oh, you're not using the file object, it's scanner sc equals new scanner, inside of that means new file.
But like.
Because input that, yeah, that's the issue, so new scanner, inside of that new capital S file.
Just call, so. Well.
Yeah,
That's.
now, what's inside of that, put input next to here, parent.
It's basically copy, right? That same thing too, because it's showing. So
Scanner.
basically, so showing the other thing in the row.
Found, so it's now just in after this, right, throw this file not found exception.
Okay, so then if J is the direction right, or
Run that sequence.
so that if J is less than. From this or J.
And then main also needs to throw a file not found exception.
That's the number, then we can do. Whatever basic.
Yeah, that's what.
Closer. Now I'm thinking we want to go back and just do what we did before with next int. Now it's a file. Now I'm thinking the next line is giving you and throwing away each line, so you're getting an end of file essentially.
Now we're gonna have to get it done. We're at 50.
You're getting the file not found exception. Let's just write this. Now we're not finding it.
It's good.
And do like kind of reason explain, just put that in there.
Yeah, start a index.
Should we take this out of source?
Build our matrix.
You can try that. I'm currently Googling where IntelliJ is moving storage. Storage user specific files. And you can comment it.
Okay, yeah.
That works there.
Kind of.
So now we're gonna send you. You just jump on these. We can check.
It's hackers. That's some kind of.
Yeah.
Yeah.
So that was- yeah, this would be right.
Gotcha.
Yeah.
Because the previous total. It's less than. I would do this.
Yeah, but finally. Because those, that may proceed does not
change.
Figure, no.
So like the cost, right?
Or,
Yeah, 'cause we're not gonna get any more road.
so that's what I was small, so you have to go find. Just go there.
I think you're good. That's good.
This is bigger than.
You may want to make sure that you've done it correctly by writing a kind of quick print method. Just doubling that so it prints exactly what you see there, and if you see that, that's great.
Yeah.
So if you're going to the right.
We'll see if it'd be whatever J is. Yeah. Times.
Are you debugging assistance needed, or?
I think we're good right now, we're still working on it.
Nice.
Going back to it's stuck in this.
This is not just one.
Change it. Yeah, it's not. Drag that in. Probably won't do it. Maybe this is, you can do it clean the whole and just get a new line. You know, because everything is senior stuff is your big blocks. Yes.
Right, we have more.
It's sort of check in. We have to like.
I think you have all the time and hit tab. Doesn't do it.
That's what it was, right?
I think it was control of stats. I said nothing, Judge.
Oh, yeah.
User calls.
I like how we have a hierarchy now.
Yeah, I just kind of all the data. Number rows, it was 20 by 20. There's a few ones,
How are people doing remotely? Any assistance I can provide?
And then we just add a space in between all the numbers too.
Yeah, because.
Oh, yes, you got it right now,
Yes, so that's why you want to go to multiple, just one of the other. And brings back.
Once you experience Python, you don't want to go back to the need efficiency.
Oh, it's because it doesn't,
That is very true.
it takes out.
Java's a nice
the
middle
leading,
ground,
so. We can do the.
Have we seen the, I need to find this feed now.
Full ends.
That's the four, so we need others. We need gray, we're gonna worry about the grading of the values, because there's the number of letters in this, so soon there's. Because we only have the largest number, 10 of these things. You don't have to worry about the stuff else.
I think I know what you're talking about. It uses.
Sometimes I actually just like, right, I change it to like and stuff. Yeah, so and actually that's name it.
I know we did.
It's yours. Total. I changed the eyes to.
Okay, question.
Yes.
It's printing fine-ish, but it takes out the leading zero in the single digit number, so it looks icky.
Yes.
There's a way to not make it
Yes.
icky, right?
Yes.
Yes.
So I actually go over that because that's kind of a good thing. Are you familiar with printf?
Yes. Yes.
All right, so we're gonna use. All right, so the question is just what goes inside of this printf? This is obviously the variable, whatever it happens to be, but on the left side in quotes. Goes some kind of format string. So what is the format string to print in exactly 2 characters? That would be, yeah, so it's some floating, so 0.2 would say that it's expecting to like a def.
Oh. 2D?
Yeah.
And then so.
And bar could be an int, but this guarantees that it prints using 2 characters.
Auto spaces.
Sorry, show those old school, C syntax.
Yeah.
Oh, we didn't have the space.
Is that what it was?
It's,
Here?
Yeah, there should be a space at the end of this to separate them. This will just print number. Yeah, you're right, absolutely. There should be a space right there.
Aha. Okay, perfect. That bothers me less. Find.
I mean.
It's not here that I'm paying computer science.
I said I hate majors.
Oh. Definitely misheard that.
Yeah.
That would also be valid. I think a lot of computer scientists hate computer science.
It's like we gotta kind of explore plus the direction that it's going.
Hopefully, I can eventually make them intuitive and make more sense.
I don't know what function do.
Just wait for linear.
So.
Linear is basically all matrices. The entire course.
Linear algebra.
Yep.
Hey,
It's the hard part of that cake.
well, because it was so.
So before you take linear, before you do that,
I can't.
find the associated
It's like the only
channel.
type of math that I'm enjoy.
Yeah. No, I'd rather just give me an equation.
And he has a series.
Or a series of equations that I need to do.
Like. The course will require you to use much more technical language than this, but this will give you all of the intuition that you need for the course. So that when someone starts talking in obtuse variables and abstract ideas, you can tie it to this series. This man is brilliant. He has the best visuals I've ever seen for almost any college math course,
We
as
watched.
well as some of the machine learning ideas, just why math is the way that it is. It is very worth just taking the time to watch most of his content, but especially right before you take an associated course. It will make that course so much easier.
We watched his videos in
Yeah.
our linear algebra class in the falls,
Yeah,
so.
I honestly think that's the best way to teach it, is you need those visuals. And unless you're a graphic artist and have tens of hours on your time to produce that in the quarter, then it's so nice. He's so good. All right, we're basically out of time, but I want to reveal where the answer is so that you know how to verify that your program is producing the correct answer. Is everyone ready? And or did someone think they found it over the course of this?
I think I found it.
Where is it?
I got 87, 97, 94, 89.
Yep, that's it. It's right here.
Better than computer.
Yeah.
That is the correct answer. So your program, when it goes through this, if it's doing what I did and is searching right, down, down right, and down left, should find it at this index, looking down left. All right, my challenge to you over the weekend, before I start assigning more stuff than you want, which will make doing things over weekends and stuff harder, crank this out. Make sure it works.
Do we get extra credit?
Every week there's, I think I've basically done so much of this that I don't know if that makes sense. I've done all of the logic here, so it's just plugging it in. I do want to make sure that people do it though. So do it, send it to me, and if you have a nice, elegant solution to this, maybe I will look at it and potentially give you some extra credit.
Cows
If it looks nice.
I'll take that.
Yeah.
Are you going to be over now?
What was the one that you showed, what was that one program that you showed us?
I'm not telling
I wanna see.
It was the one that was extremely simple, but extremely long for no reason.
Oh, yeah, The Big Buzz problem, Big Buzz Enterprise Edition.
What if I just do the bid, like, what if I just do this, but bid, but I want to.
It's so easy, it's two text you can do it. With regular FizzBuzz, I think that's the idea. It's not even a 212 level problem. You can apply all of the stuff we're gonna talk about in this course to that problem, but you should not. All right, thanks, everybody. See you on Monday for going over exams and the strategy pattern.